Hey guys, how are you doing? Today we'll see how to draw a function using everything that we have learned so far. Specifically, we'll draw the function f of x equal to e to the minus 2x squared divided by 1 minus x squared. So grab your pen and paper and I'll see you in a minute. Whenever you have to draw a function, the first thing you do is to compute its domain. So this function has only one problem, that the denominator might be equal to 0. And we don't like to divide by 0, which means that I have to impose that 1 minus x squared has to be different from 0. And this means that x squared has to be different from 1, which implies that x has to be different from plus and minus 1. So since we want to draw the function, what we do to remember the domain, so what I usually like to do is I'm gonna put a minus 1 here on the graph and a plus 1. And then to remember that I had to exclude these two values, I'm just gonna draw a little dotted line above minus 1 and another dotted line above 1. So now I do remember that here something weird has to happen, okay? Because the function is not defined, which means that the function might have some really weird behavior. The second step in the process is to understand when the function is positive or negative. How you do it? Well, you want to see when the function f of x, for example, is bigger than equal than 0. So what you do? You just impose that e to the minus 2x squared divided by 1 minus x squared has to be bigger than equal than 0. And now we have to think a little bit, because for instance the numerator can never be negative or even equal to 0 because it's an exponential. So we can divide by it on both sides, and we deduce that our function is positive when 1 over 1 minus x squared is bigger than equal than 0. Well, but now we know that this denominator is equal to 0 when x is equal to plus or minus 1. We just did that 2 seconds ago. So we are ready to draw the sign chart of all this fraction in the following way. So we draw our line, we put our two vertical asymptote, minus 1 and 1. And then we are going to evaluate the function in between. We can evaluate the function at 0, at 2, and at minus 2 to understand its sign. So for x equal to 0, the value of our function is 1, because I just plug into 0, I get 1 over 1, so it's positive. When I plug into x equal to 2, I get 1 over 1 minus 2 squared is 4, so 1 over minus 3, which is negative 1 over 3, which is a negative number, so it's going to be negative. And when x is equal to minus 2, then I'm going to get the same things, because x squared, minus 2 squared is the same as 2 squared, so I'm going to get a negative number. Which means that the function is positive for x between minus 1 and 1, and the function is negative for x smaller than minus 1 or bigger than 1. Again, we have to report this in the graph. And how do you do it? Well, what I like to do here is that I'm gonna take another color and I'm gonna say, well, I know that between minus 1 and 1 the function is positive, so I'm gonna exclude this area. And I know that outside minus 1, 1, the function is negative, so I'm going to exclude this area. These are going to be pretty helpful when I'm going to compute the limit at the extreme of the domain in the next step, because I know already where the function can go. For example, if I get the limit as x going to minus 1 from the right hand side, from minus 1 plus, is some negative number, where there is something wrong here, because the function will go down here. And I just excluded that the function can go down there. So it's a good way also of checking if we are doing things correctly. The third step is to compute the limit at the extreme of the domain. What do I mean by that? Well, the domain of our function, we said before, is x different from plus and minus 1. Let's write it as a set. So the set is t equal to the interval minus infinity up until minus 1, union the set minus 1, 1, union 1 plus infinity. Now, when you consider limit at the extreme of the domain, I mean that you have to take limit for each extreme of these three sets that you wrote down here, okay? So in particular, we're going to take the limit as x goes to minus infinity. And since this minus 1 is on the right-hand side of a domain, this means that x is approaching minus 1 as x goes to minus 1 minus, so from the left-hand side. Now, whenever we see a number on the left side of the domain, where the limit is going to be towards that number from the right-hand side, okay? And here, minus 1 and 1 coincide, so we have to take the limit 1 from the left and 1 from the right. Same thing is going to happen for 1, so we are going to take a left and right limit. Indeed, you see that 1 appears as a rightmost extreme of an interval and a leftmost extreme of the other interval. And then the last one is the limit as x goes to plus infinity. So let's start from the limit as x goes to minus infinity. So let's go in order. Limit as x goes to minus infinity of e to the minus 2x squared divided by 1 minus x squared. Now, if you plug in the value as x goes to minus infinity, here we have e to the minus x squared, so minus infinity squared is still infinity, but with a plus, so is e to the minus infinity, which is 0. And on the other side, we get 1 minus x squared goes to minus infinity, so x squared goes to plus infinity, so we get infinity, so this is 0. And now we know that our function after minus 1, so on this side, has to be negative, which means that the function is going to go somewhere in this direction here. And that's how I sign that this limit as x goes to minus infinity. So I just draw this little line. Then we can compute the limit as x goes to minus 1 minus, from the left-hand side, of e to the minus 2x squared divided by 1 minus x squared. Now, since minus 1 is one of the 0 of the denominator, I have to be a bit careful. And a good way of being careful is actually rewriting all this fraction, but with the denominator simplified a little bit. And what I mean by that we can factor the denominator. Indeed, is equal just to the limit as x goes to minus 1 minus of e to the minus 2x squared divided by 1 minus x times 1 plus x. And now this limit is a bit easier to compute. Indeed, if we plug into x equal to minus 1 minus, what do we get? At the numerator, we get a number, so it's going to be e to the minus 2 times minus 1 squared, so e to the minus 2. Divided by, when we plug minus 1 into 1 minus x, we are going to get 2. So 2. Times, and now some things might go wrong. Indeed, 1 minus 1 is going to be equal to 0 here. But we are approaching minus 1 from the left-hand side. So x is going to be something slightly smaller than minus 1. It's going to be minus 1.1, which means that 1 minus 1.1 is something negative, which means that we are approaching 0 minus. So a negative number. And now we have a positive number divided by 2 times a 0 minus, which is slightly negative. So we're going to get minus infinity. Why is that? Because again, we are dividing by 0, so we're going to get infinity somehow. And the sign is determined by the sign of all this fraction, and we have a positive number divided by something positive times something negative. Okay, so that's why we get a minus sign. On the graph, how do I report this? Well, minus 1 minus going to minus infinity, which means that the function is going to go in this way. So this one also is a good check to see that the positivity calculation that we did before actually makes sense. Indeed, this limit here and minus infinity is good. It couldn't be plus infinity because here the function is not defined at all. So now we have to compute the limit from the right hand side. So the limit as x goes to minus 1 plus of e to the minus 2x squared divided by 1 minus x squared, but we know that we can factor it as 1 minus x times 1 plus x. And now when we plug into minus 1 plus, we are going to get in the numerator e to the minus 2, again, divided by minus x is minus 1, so minus x is plus 1, so it's 1 plus 1, you're going to get 2, times 1 plus x now, that we have to be careful. Now x approaches minus 1 from the right hand side, so we have to plug in, for example, x equal to 0.9 negative sign, so minus 0.9, so we have 1 minus 0.9, which means that we are going to get that 0 plus here. And now we are dividing by 0, so we are going to get infinity somehow, and all these numbers are positive, which means that we are going to approach plus infinity. Now let's report this on the graph, and we have to draw a little line on the up corner here, because again the function, whenever we are going to approach minus 1 from the right hand side, is going to go something like this. And again, even this calculation is coherent what we have done before, because we cannot go on the negative side between minus 1 and 1 because the function has to be positive, and indeed we are approaching plus infinity. Now the limit at 1, let's start with the left limit, so let's compute the limit as x approaches 1 from the left side, so 1 minus of e to the minus 2x squared divided by 1 minus x times 1 plus x. And now the numerator is always easy, we are going to get e to the minus 2 divided by 1 minus 1 is 0, but we are approaching 1 from the left hand side, so because the limit is at 1 minus, which means that we can just plug into x equal to 0.9, for example, so 1 minus 0.9 is something positive, so this is going to be a 0 plus times 2, and now we are dividing by 0, so we're going to get infinity, and then since all these numbers are positive, we are going to get plus infinity. Let's report it to the graph. So now you see that the function has to go here as x approaches 1 from the left hand side, and again we expect the function to behave something like this. And again, this is coherent with what we've done before, the last two limits. So now we're going to compute the limit as x approaches minus 1 from the right hand side, so 1 plus of e to the minus 2x divided by 1 minus x times 1 plus x. And again, this is going to be equal to e to the minus 2 divided by, now 1 minus 1 is going to be 0, but we are approaching from the right hand side, so something slightly bigger than 0, so it's 1 minus 1.1, which is negative, so we're going to get a 0 minus times 2. And well, we're going to get infinity because we are dividing by 0, but now this number is positive, 2 is positive, but 0 minus is negative, so we are approaching negative infinity. And we report this to the graph we have up here. We see that we are approaching negative infinity on this side. Perfect. Last limit. So we're going to compute the limit as x approaches plus infinity of e to the minus 2x squared divided by 1 minus x times 1 plus x. And here is a no-brainer. Indeed, e to the minus infinity is going to be 0, divided by 1 minus infinity, 1 plus infinity is going to be still minus infinity times infinity, which is negative infinity, but this number is still 0. And again, in view of the positivity, we know that we are going to approach 0 from the bottom here. So that's the limit for the domain, and now we can start to study the extreme value of the function. The last bit of information that we need to draw our function are its local maxima and minima. How we compute them? Well, the usual way. We compute the first derivative and we impose it to be equal to 0 to find the critical points, and then we are going to use the first derivative test to understand if the function is increasing, decreasing, and whenever it has a local maxima or local minima. So let's compute the first derivative, f prime of x. This is equal to big fraction because we are going to get a long expression here. So it's a quotient rule, so we're going to get 1 minus x squared, everything squared. Then the derivative of the numerator is e to the negative 2x squared times the derivative of the exponent, which is minus 4x, times the denominator, so 1 minus x squared, minus the derivative of the denominator, which is negative 2x, so we get plus 2x times the numerator, e to the negative 2x squared. And now we have to impose this guy to be equal to 0. We can factor the exponential part, and we can also factor these 2x terms from both of these guys. So we get that e to the negative 2x squared times 2x, all divided by 1 minus x squared squared times, so we factor e to the negative 2x times 2x, which means that here what's left is negative 2 plus 2x squared, and we factor all this guy, which means that we are left only with 1. So plus 1. This has to be equal to 0. We can further simplify it as e to the negative 2x squared, the 2 up in front here, x times 2x squared minus 1, all divided by 1 minus x squared squared. And this has to be equal to 0. When this fraction is equal to 0, when the numerator is equal to 0, and in the numerator we have this exponent here that is never going to be 0 because it's an exponential, which means that the only term that can be equal to 0 is this polynomial. And in particular, this polynomial is factor, so it's easy to compute its zeros, which are x equal to 0 and 2x squared minus 1 equal to 0, which means that x can be equal to 0 or x squared has to be equal to 1/2, which means x equal to 0, x equal to plus 1 over square root of 2, or x equal to negative 1 over square root of 2. And now what's left? Only to compute the sign chart of the first derivative. So we have the 0 of the numerator, so that's perfect. And now we have to compute the 0 of the denominator, but those are not easy because we got again 1 minus x squared, so we know that the 0 is going to be plus and minus 1. And now what you do is just draw the sign chart of this first derivative to figure it out when you have a max or a min. So let's keep it like this. Long line. So we have 0 plus 1 over square root of 2. Then we have 1. And on the right hand side we have negative 1 over square root of 2 and negative 1. And now we have to evaluate the function in each of these interval. So between 0 and 1 over square root of 2, there is the point 1/2. Same things here, negative 1/2. After 1 we have 2, and before minus 1 we have minus 2. That's easy. And now the hard part is to find something between 1 over square root of 2 and 1. Well, what we can do, we say we can take 1 plus 1 over square root of 2 and then divide everything by 2. And so we know that this point is going to be between 1 over square root of 2 and 1. Now this point is 1 over square root of 2. I can rewrite this everything as square root of 2 plus 1 divided by 2 square root of 2. Okay? It's a weird number, but just bear with me. It's not going to be that hard. So this point here, it's exactly here, and with a negative sign, it's going to be between these two lines. So when x is equal to negative 2, everything is really easy. Why? Because this exponent is going to be positive. This denominator is going to be positive always because we have a square here. So whenever it's not 0, it's going to be positive. Now x has the same sign as whatever we are plugging it here. So if it's a negative 2, it's going to be negative. And now this guy is a parabola, right? It's a parabola, and its 0 are 1 over square root of 2 and negative 1 over square root of 2. So when we can draw this parabola like this. So these are the two zeros. And so we know immediately that if we evaluate this function in between the two zeros, which are negative 1 over square root of 2 and 1 over square root of 2, we're going to get something negative. And if we evaluate it from outside, we're going to get something positive. Great. Now, which means that we evaluate everything for x equal to negative 2. The exponential is going to be positive, the denominator is going to be positive, this guy is going to be negative, and this guy is going to be positive. So I have all of this, which means that the function is negative. So I have a negative sign here. Now, between minus 1 and negative 1 over square root of 2, there is this point, so you can evaluate the function at this point, or try to reason in this way. So we are here. So we are in this interval. The exponential is going to be always positive. The denominator is always going to be positive too because it's something squared. X, now we are living in the negative part of the real axis, which means x is going to be negative. So this is going to be negative. And now 2x squared minus 1, we're evaluating it at a point which is before negative 1 over square root of 2. So it's going to be positive. Oh, well, this means that this is positive. This is negative, this is positive, this is positive, the function is negative. So I get a negative sign. And we can continue like that. So in the same way as before, and here we're going to get a plus sign, here we're going to get a negative sign, and here we're going to get a plus sign, and then another plus sign, okay? And I keep repeating the same kind of reasoning that I did before. Well, now we can draw the chart of the function. How does it look? So the function is going to be decreasing, then decreasing again, that is going to increase, then it's going to decrease, then it's going to increase again. Which means that for x equal to 0, I'm going to have a local maxima, and for x equal to 1 over square root of 2 and negative 1 over square root of 2, I'm going to have two minima. We can now report what we learned on the graph. So we have that the function is decreasing up until negative 1 also. So we're going to get that is decreasing here in this way. And now from minus 1 up until negative 1 over square root of 2 is going to decrease. So let's report negative 1 over square root of 2 here. And you're going to get plus 1 over square root of 2. So the function will be decreasing up until there, and then a minimum at negative 1 over square root of 2. So it's going to do something like this probably. Then it's going to go up again. And at 0, we're going to get a maximum. So something like this. And then at 1 over square root of 2, we're going to get a new minimum. Like that, and then we're going to go up again. And for the remaining part, from 1 up until infinity, the function is going to increase, so we're going to do something like that. Perfect. We have drawn our function, and now let's just enjoy Manin plotting it for us, actually. That's all I have for you for today. See you next time.